So in this week, we're going to talk about forensic processes. Some of this is going to be review for many of you who had taken CIS-27A a while back. It's going to run again in the fall. I used to teach it, but okay. So in this week, we're gonna talk about forensic tool. I think that it's forensic is very important in cybersecurity analysis. As you saw with Canvas, right? After the fact or even during the incident, you have to kind of perform forensic to kind of see what had happened, how did the attack happen, how did they get in, what kind of system was impacted, and so. And we will start with, the process, the tools, and then we'll get into the actual system and then the networks. Um, so in forensic, when you are performing forensic, it's important that you use a powerful system to do the analysis. So in the first question, it asks you what type of tools do you need to perform computer forensic analysis? Um, we typically use a virtual machine in class only because it's accessible to you. But if this is done in the real world environment, you would use a powerful system like the one that you're sitting at. So you need to have fast and many cores CPU. So if your computer has a more modern CPU, that will be ideal. Some companies sells digital forensic computers and laptop for a very high price, between $7,000 to $15,000. So if you're looking at the specification, it would be equivalent to what you see as a powerful gaming computer, right? So you're gonna need computer with fast CPU. You're gonna need a large amount of RAM. And I think the standard now that when you're buying a computer, you typically see 16 gigabyte of RAM, right? It might be running DDR4, or typically the more high-end system uses DDR5. And of course, RAM is like the cost of RAM still, right? Storage is still pretty high. But I would recommend at least 16 gig, but typically we would go with 32 gig or higher if you can. When you buy a digital forensic system, they would come equipped with at least 32 gig of RAM these days, right? Sometime more. You need to have a good internal drive, like a solid state drive, that's going to be allowing you to run operating system. The RAM, the CPU, and the disk storage allows you to run more powerful applications. When we perform forensic, we utilize a lot of the resources to perform the scan of the data set. And the data set really consists of images that you create, and we'll talk about it more in the later questions. Also recommended that you are using good GPU, so graphic processing unit. If you have a gaming video adapter, that's probably pretty good. Some board comes with really decent built-in graphic adapter, right, or graphic component. So you can look at that option if you're looking to get into this area. Now, if you want to get a bachelor in cybersecurity with digital forensic analysis, Cal Poly Pomona has the degree. It is really geared for that, right? And in this area, you have a set of certification that is broad, kind of like CompTIA, but it's offered by GIAC. Or you can go into specific vendor like NCASE, and so on. But so after the hardware, you're gonna need to have the software. There are really good open source one. I think some of you already saw some of that in CIS-27A. But forensic tools would come in a group. It would allow you to do analysis on email, right? Storage, like file carving. And also you can perform analysis on social media, mobile devices, components that belongs to portable devices like micro SD, SIM, and so on. So The software part, it's really up to the direction of your forensic, but typically you see FTK, that's a brand. FTK really stands for Forensic Toolkit, but the brand is also called FTK. You also see NCASE. NCASE is very, very popular with public sector, like government agency, police department, etc. Right? Digital forensic is an area if you only want to be like a technician or an investigator, right? It is harder to get into that niche. You typically have to come in as an intern to build some experience. So if you like this stuff, you would need to seek the opportunity to excel in it. But as an analyst, you need to perform in cybersecurity, we need to perform digital forensic in many different areas. You are going to need a write blocker. This is a device that you would use to prevent modification to your data. You would plug that in with your drive. So for example, if I have USB drive that I'm using for analysis, right? Let's say I found a USB in the parking lot. I wanted to analyze that USB. I would use a write blocker with that USB to prevent my system changes applied to the USB. So we don't want additional data to the actual evidence or the artifact. You would also need to get a drive duplicator. I don't know if you have seen these. They come in various model, right? If you're working with an older computer, right, that's using hard drive, there's a bay that you would plug the drive in, or a solid state connection or the port. And there are two bays. So you're able to take one drive out of the computer, plug it in, and then you would put a new drive on the second bay and you plug it into your system. What it does is it duplicates the drive exactly to the second drive, right? And it's a good way for us to be able to replicate the data set that we originally get to a backup data set. I always recommend that if you capture an image, have a secondary image, because in case something happens to your first image or your first data set, you're able to have a fallback. And then recommended, I think in a lot of places, right? Like if you're working for a security service company or at the police department, you typically would have a network drive or network systems that allows you to store, right, your investigation or your project in the investigation on there. And you should be able to have a backup. Now, can we do this internally in our internal network? Sure, right? You can set up a network attached storage and then dedicate, right, a folder or container on there and be able to put your project on there. And then update it throughout. But make sure you password protect and encrypt it, because in a lot of the forensic process, we typically analyze things that are very sensitive, right? Like sometimes a fraudulent case, sometimes an attack, where it should be private until the company makes it public information. So you don't want that to fall into the wrong hand. I recommend using a digital camera. So if you are hired as an analyst and you work in a SOC or the Security Operations Center, right? Don't use your personal phone to take pictures or things that are related to forensic cases, because the way that when things go to court, right, they might need your device to be able to also analyze by a third party, and you don't want contamination across. So use a digital camera that has the capability to take picture and record, right? And then when you have that on micro SD or a storage area, you can back it up. Various cables, right? And then we'll expand a little bit on that. So USB cable, network cables, drive cables, those cables are important because you never know what kind of system that you're gonna get. Sometimes legacy systems, sometimes newer systems, sometimes iOS devices. So make sure you have Apple type of cables. And then your drive adapter like SATA. right? For serial ATA for the old hard drive, or more modern type of cable for the newer drives. Okay. Drive adapters. I recommend having labels because you have to do inventory of systems that you acquire. When you work for law enforcement, sometime when they confiscate system, it might not just be one or two, right? If there's a raid at a facility where they pull 100 systems, you have to be able to label them, right? And then you have to document the specification of those systems because take pictures and then they would get transported into evidence locker or warehouses. And you typically see that, right? So if you work for agencies or things like that, you might deal with many computers, many systems, many laptops. Having, yes, I was just talking about like who handwrites things anymore. But in the case where you don't have access to digital equipment to print, right, you should be able to have markers and things that you can label real quick, and then you can create digital labels down the line. But just making sure that we can use that to take notes and make notes. And then having chain of custody form. I think on the notes, I put a link for this template. If you work for a company that doesn't have a form, you can use a template and modify it. Typically, if you work in law enforcement, you have to use their form, or if you work for FBI, CIA, things like that, right? DOD, they will provide you with a form. Typically, a technician or a forensic investigator at these organizations, you must go through the training and the certification. So, and some certification required you have the backup experience and the time, right? So these are the elements or the components that you need to begin and continue with your forensic investigation. Question 2, what type of tools are needed to perform mobile system forensic? So everybody now have wireless network and they allow users to bring their devices to work like smartphone. But in the larger aspect, if you're looking at criminal investigation, right, a lot of the things can be acquired from the mobile, would be like text messages, chat, email communications, images, videos, things like that. If you ever watch true crime videos and if they share information about how they pull data on like search, things like that, right? So a digital forensic investigator, typically they have to find like what kind of things that people download, what kind of things that they search for, like murder weapons, chemicals to commit the murder, etc. Right? Or in the case of trafficking, things like that. So you would need to have SIM card reader because mobile devices have SIM for mobile network communication. You would need to have micro SD card adapter. I think on the Android platforms, you typically see micro SD being used. I think more of the recent Android systems use internal storage because they want to sell storage with the system, right? And you see that more predominantly on the Apple side as well. But you would need to have some kind of micro SD card adapter or reader. You will find a lot of these have the capability to use like USB or USB-C. I have quite a few because I work with IoT devices. So I would use micro SD reader with USB so I can quickly transfer information. And then you would need to have specific cables for mobile devices, right? I know Apple has specific cables. Now they're really pushing for newer cables with newer Apple products. So you have to think about like the type of systems that you're working with. And then your USBs, which is universal to most of the computing system, like mini, micro, and C. And then like lightning cables, software tools for mobile forensic. But if you're using a lot of the forensic toolkit, it has the capability to do mobile system analysis as well, right? All you have to do is capture the image of that system. And some software tools have more features, right? Like for example, if you are investigating specifically email communication, it can also pull like deleted text messages, right? So because on the flash storage or internal storage of a lot of the mobile devices, right? Slack space is typical where things don't get written over unless you have files that go on top of it. So that's how they're able to pull a lot of information from your device. Okay. Any question? Okay, so as you're working ahead, I want to come back to, not that one, to your notes, right? It gives you the specific information about the tools that you need, and the reason why. And then the template for chain of custody is right here. Now, if you're using FTK or NK's product, right, you can find their resources via their link, right? These are proprietary tools. And then in the next section, which is page 2, it talks about mobile device forensic. Next, we're going to talk about forensic software and the reason why we use it. So one of the projects that I give in CIS-41A is a USB, right? I give the student a USB. I have the student make an image of that USB and then be able to analyze it. You have an option to use your forensic toolkit, right? Open source or commercial to be able to capture the image. That is called the image utility, okay? Imaging utility is a software that takes the information, the data of that system in its state, right? So in forensic, the way that we look at data, there are elements or attributes to the data where we would see like when was the data created, right? When it was last accessed, when was it modified, right? And some of you are still remembering what we talked about in the other class. That's called a map, right? Modified, accessed, and created. So if you just simply take the device and you open up the file, it changes the last access time, right? And you don't want that because let's say that you are investigating a case of an employee, right, that's leaking data. And you wanted to see like what kind of data they access, they pull, how did the data exit the facility. So if you open up the computer, their computer, and be able to look at the data that they access, if you open up that file, it actually create a timestamp that when you open the file, not when they open the file. So the imaging system allows you to capture the system information, especially disk storage, right? Where the data sits. So in Windows environment, what you see is, right, like the data might be in documents, might be in specific folder, right? The folder might be linked to the OneDrive. It will be on a certain section or the partition of the disk, right? Or it could be in a logical volume. So partitions are like rooms in a house. So you can have a disk, and you can cut the disk up to many different sections, and then you can label certain sections for certain purpose. Like I would have a master bedroom, right? Or a kitchen or a living room. So what you see is that when we're imaging, it captures your system state, right, of the data inside the storage, okay? But with that, it also captured things like information that was stored with cookies or search engines, so we can find things like what kind of details they were searching for, or things that were temporary download, like images, stuff like that from email. So there are many different elements, and it really depends on the purpose of your investigation. However, never ever open the files in the system that you are investigating, right? We want to use an imaging utility to create the image where it captures the data, the application, and the system state. Because if you open things up that's over, right? Then you're gonna have to say like why things were not how it was originally there. So if it goes to court, that gets thrown out because your evidence is contaminated and you don't want that to happen. Okay. So imaging utility is the first tool that you should use, right? To create the image. Then the second tool that you would use is your forensic suite. And in the case where the utility for imaging is built in with this, then you only need one set of tools. Okay. All right, any question? Okay, so we can find this information. I keep opening the lab. Right here on page 2. Next, we're going to talk about these two areas. So you can see now, like, why do I need to take CIS-25? Right? Why do I need to take? Because in security, we touch back into hardware analysis, right? You have to know about firmware, you have to know about how application works, you have to know about how hardware works, and that how the network connects together. So it's really important that like the layout of all of these classes would be built into some of the skill sets that you need in specific area in cybersecurity. Do I need to be an expert in forensic in order to work as a security professional? No, right? But you need to know how to do it. Because one way or another, you're going to come across things like this when you're responding to an incident, when you are helping someone looking back at how things happen, you have to perform forensic. And that's very important. I know that this is not favorite and for many, and it's not one of mine also. It's interesting, but the forensic part I like to do is I typically like to do malware analysis, or network analysis, but like attack breach kind of deal. However, like looking for files and things accessed, that's an important area for cybersecurity. So with that, we're going to talk about storage. Okay. And when you perform file carving, so file carving really means that at the low level, you have to really look at like where does the file sit, okay? This comes back to file system, operating system, and your storage, your hard disk or your SSD. Now, in dynamic storage, that just means that your drive, right, solid state or hard drive, what it does is it throws data in wherever it can find. So on your disk, it doesn't necessarily mean that all the data are together, right? Your files might be spread across, your files might be in different locations, but most importantly, the slack space is where the space of the files that have been deleted, right? Or the sections of the drive that has been deleted, right? Which is, it comes back to the unallocated. So if I have, let's say 100 files and now I'm a disgruntled employee before I get fired, I'm going to quit and I'm going to delete the 100 files. So when I put it into the trash can or the recycle bin, right, and I click empty, the space of that 100 files becomes slack space, right? So your system take that space and make it available for the new files that's going to go in there. So in forensic, that's important for us because if we need to go back and look for deleted files by this disgruntled employee, we need to carve it out from the slack space. And when you look at file carving on drives, doesn't matter if it's hard drive or solid state drive, they are hexadecimal values, right? You might see like X00, right? That's the header of that partition. So we would know that all files have file headers. File headers are like labeled to the file. It tells the system what kind of file it is, right? What's the name of the file? What's the attribute of the file? It contains metadata. And even if you cannot carve out the content of the file, that piece of information is important because if we can find some details about the files from the slack space, it gives some leverage in either winning or losing the case, right? Or, having some progress in that particular case. So what you see is that you need to look for hidden files, deleted files, and fragmented files in the Slack space. So fragment files just means that when you create file one, it doesn't necessarily put it in one location, right? It might put it here and there, because your system dynamically stores so that way it can quickly store the files. And in the fragment option, traditionally you see this in Windows system when you use a defragmenter, right? Now they relabel that as a different tool. It would group all the addresses in that storage and put it together, right? So if you defragment a file, all that means is that instead of spreading it across the disk, right, it would group the addresses is more adjacent. So it's kind of like on my street, I own 10 houses, and I would put my clothes in one house and my shoes in another house, and my car in the third house. And so when I need to go get ready for work, I have to go to these houses to pull all my stuff, right? So fragment files, when the system needs to pull it, it needs to, one, look at the header of the file. Then second, it needs to go and find the addresses where the files are located. So your disk contain addresses just like RAM, right? Certain address would have pieces of the files, and that's how it's able to pull the file. So every system now does dynamic storage, right? Not just the computer, but when you're looking at your phone and everything else, right? So it's a quick way for us to really utilize the storage in a very quick and a higher performance level. Okay, so we want to look into the Slack space, and an unallocated space is like the empty space in a house, right? That space is not furnished. That space is not used, right? So let's say that you have a new home and they haven't built out the rooms, right? It's just the frame of the house. So your disk has these unallocated space, right, that can be used to hide files. So from an advanced attacker standpoint, they can put things into Slack space and unallocated space, right? Trying to hide that information from you. So what we want to do is we want to carve out the data from these spaces, right? So in a system, if I have 1 terabyte and I only use 500 gig for my C drive, right? The unallocated space is the leftover 500 gig, or a little bit less, because your Windows system use a little bit of it for boot sector and so on. Question? Okay, so we talked about the image utility. Now we're going to talk about forensic analysis utility. So forensic toolkit is part of your forensic analysis utility. This is used to, number one, right, look at events that are happening to the system, right? If someone is using an application like Microsoft Word or even a browser, it logs that information. It would say that this system had used this particular browser at this time. Why are we on warmer in here? Sorry, someone in the morning had kept it on warmer. It's so hot in here. Any question? So when you use forensic toolkit or forensic tool applications, right, we use this with the image that we capture. Never, right, open the system on its own. I got a lot of project from 27A, I'm not gonna lie, that students had just opened up my USB and looked at it. I can tell because when we return the project and how they screen capture and what their USB, I can tell that they didn't create an image, right? So because I can find, using my own forensic toolkit, I can find that they open up the files. And you don't want to open up the system data. You want to capture, right, through an image utility so it doesn't change its state. Now, that's not 100% guarantee. Some software application does have a little bit of change when it accesses a certain thing. So you need to know what that is and document it on your report. Okay? So we want to look at the system changes, right? If there's configuration change. So in the case of like a breach, an attack, when you're looking at the server system, typically we start with network analysis, right? The capture of the network, and then we dive into the specific system that was targeted. So when you look at that, you wanted to see, number one, was its logs changed, right? Log files, was it modified? Number two, right, was configuration change, right? Number three, right? So if there's changes, you move from there to the next step. So you would explore to see, right? You would look into the logs, you would look into the content of the logs from the image, and then you would start diving into, so if it's DNS related, I would start looking at DNS records. If it's, web server related, right? I looked at the services, I looked at the configuration, and then I would look to see if there's modified in the content of my web server. Okay. So good files, deleted files, the metadata on the file, which is like the property of the file. Then you file carve, right? So if you don't know like what kind of data that is, right? Your system, your application will allow you to pull specific information about the file, like where it actually stored, what kind of file header, what's in its content. Sometimes images will come up with just like a little icon, but you cannot, it cannot recreate the image if it was deleted or it partially corrupted or something like that. Okay. Now in Windows environment, we talked about this extensively last time, that registry really store a lot of information about your hardware and software. So if you are performing forensic on Windows system, this is a very important area, is the registry analysis. Now, some forensic toolkit would have this component. Some doesn't, then you have to manually do this or use another application with that. Okay. Question? Okay. So for today and later in the lab, you are using a different virtual machine. It's not going to be Kali Linux. Can you use Kali Linux to do the same thing? You can. I want to introduce you to a specific virtual machine that is really used for portable executable, which is your PE, your EXE analysis with malware, right? Why do I always have lab about malware? You as a user are exposed to malware a lot. Likely that when you go to the security area, you are going to see 50% of your work is going to be dedicated to that. Ransomware, Trojan, polymorphous, all kinds of malware that will surface with different forms of attack, right? So I want to show you that you can use specific tools for this area, forensic. Question? Okay, let's move 6 up so we can continue with the last few questions. So this is kind of long. We don't have to put verbatim, right? In the last question, there was indication about file carving. We want to talk a little bit more about that in question 6. So we want to explain the purpose of file carving in forensic, right? Because this process can be very lengthy if the system contains a lot of files. And when you're looking at the server environment, let's take storage server, for example, right? Storage server originally would just be like your file server, but Microsoft doesn't call file server anymore, storage server. So something like SharePoint on the cloud, which is like a remote server that the user can back up their data to the OneDrive, right? So it has these drives, which is container, and inside the drive you have folders and files. So you need to carve out a lot of the files. So when you use Forensic Toolkit, if it has a file carving tool, then you can use this feature of it. If you don't have a file carving tool with your Forensic Toolkit, then you have to use a separate tool. But ultimately, file carving tools looks at the data or your files based on the location of the file on the disk. Like I said, at the address of your disk. So inside the disk, you have an array of addresses, right? Like I said, like a block in your neighborhood would have address number 1150, 1151, 1152, and so on. And that continues. So you would have files that are spread across those addresses. So what the system does is it takes a chunk, right? So your data, it can be a lot, right? A file can be small, right? Like 2 MB, right? Or large, right? Like in the gigs. So if you're looking at like videos and more like graphic based file, that can be a lot. So what it does is it chunks it up into blocks. And it would look at these blocks at the address. Okay. So it's kind of like I'm looking into a specific house in the neighborhood, right? On that street. And now I'm looking into like section of the house where like the garage or living room, right? Like so even smaller than that. Okay, so it does block by block analysis. And it would start with looking at the file header. File header, there's a location on the disk for the file header. And if you read the notes, it talks about like the hex value. So you typically see 2 hex characters, right? And if you have taken classes that talk about hexadecimal value, a hex, right? 1 character is equivalent to 4 bits. 2 characters gives you 8 bits, which is a byte, right? And so when it carves, it's going to look at one area that's going to have like this hex value. For example, like 00 or 0F, right? So it's going to pull the file header information at that specific location. And the file header is going to give us the application, the details, like what kind of file it is, like what I talked about. And then in the next area, it's going to look at pieces, right? Or the next few part of the files through the blocks. Okay. And that's how it carves out. And this can be very long if you have slow processor, right? So if you're running your application on a slow computer and you're trying to carve a lot of file, forensic, where you're going to spend a lot of hours if you're working with like very large system, okay? And some of you have experienced this. You're like 30 minutes in, Dr. Nguyen, I'm scanning and then I don't get anything. That's typical, right? So you typically see that when you carve files, if you have a lot of files, it's going to take time. So be patient. All right. So we talked about, it starts with pulling the header and the footer information. So it gives you the nature of the file or the properties of the file. Then it's going to move into the pieces that would make the content of the file, right? Like if you have a JPEG, it's going to try to build out like pieces that would be like pixels that would generate images for the bigger piece of the file. Okay. So, and in this part, right, depending on the application that's used for that file, so if you're looking at image file, right, you typically would have application that would be encoded to generate that file. Compare text document to image file or video files, that's different. So in a text format, you would typically see that it carved out by characters, right, based on text recognition. Now, if you compare things like Notepad versus Word, right, the encoding is different for the application. And some application, most application now on standard use like UTF-8, but you would see some that use ASCII or different encoding systems. So it utilized the encoding system to really perform the content analysis to give you what you would see as text or content of that file. And then next, it's then going to carve using file structure technique. And so that would give you the information about the structure of the file. So, you know, in analysis, we always look at like file related to application, and I think we talked about this in extent. But in, looking back, right, when you perform file carving, it goes through this process to give you the details. Is it guaranteed that you're gonna get something? Not necessarily, right? I talked to a lot of my friends about like, have you ever come across such incident, right? And all of us think that in security, sometimes in analysis, you advance 3 step, and then at some point we might go back to the original because you thought that you had some information, but it didn't take you anywhere. So you go into a dead end. And then you start all over again. And that happens a lot in forensic. Okay. So, any question? But that shouldn't deter you though, right? So, we tend to be more like, oh, I want some kind of output, some kind of result because I run a tool and I'm analyzing and I need to generate a report. And I have a timeline, right? I have a period of time that I need to provide the report to, my supervisor, my client. But sometimes, you can't get a lot of information even if you spend a lot of time on it. Okay. So you got to make sure that you buffer, you prepare and plan accordingly. Sure. Yeah, it's a very special niche. If you look for forensic, typically the people that they have trained and groomed, usually the ones that are hired. Now you don't see a lot of companies are focusing on, doing digital forensic. You would see like forensic being used in cybersecurity. You might work for e-discovery or specific forensic companies that would perform like for legal, that is used for legal hold and used by agency. But so yeah, that will probably be the main thing. So like I said, if you want to get into this area, right, get a special certifications for it. Okay. We used to offer voucher for CTF, but there was not a lot of bucks, so I stopped buying it years ago. However, the exam can be difficult. But you need to know how to do forensic and cybersecurity, period. Like, no question about it. You don't have to like it. But you need to know how to do it. It's kind of like one of those things that you must do. And if you enjoy doing this, right, you can make a living out of it. Like I said, it's a niche and it's far and few. So if you are specialized in it, you can make a lot of money doing it. You can be an expert in it. Like they can contract you to go testify in court to validate or debunk whoever says what, right? And you see a lot of different federal cases that are related to tech companies right now, right? Relating to the legal aspect, compliance, and privacy. All of those require expert when they go to court. So, question? Okay, let's talk about chain of custody. Okay. Just like ethical hacking, we do not perform anything until we're authorized to do that. A lot of the things that you're going to be doing, you cannot disclose sometimes, right? But chain of custody assure us that there's a process in tracking. You need to record every single step of the things that you're doing, starting from when the incident happened. So let's say I have a friend that is now working for San Bernardino County at the upper level. She tells me that whenever there's like cases like murder, human trafficking, stuff like that, forensic people at the county shows up. Digital forensic people, right? Because now it's involved like things like the smartphones they use, stuff like that. So anyway, in that she has to include chain of custody. So you use a form and you document. Let's say that you have a computer that you confiscate. You take a picture, you tag it, right? They use special tags. Sometimes you have to create a label, and then you document it on the form. I blah blah blah, right? At this date, blah blah blah, right? Acquire this systems, right, in this state. Okay. And so with that, you would be able to document, and then when that gets transported and it handed over to someone else, right, like another technician, then they add it to that form. So chain of custody allows us to track the things, to log, right, to ensure that your systems go through the process or recorded in the process of investigation. And then when you're working with drive images, right, like creating the image, analyzing the image, you have to also include that. So it ensures, it says, right, that the drive images and other data can be validated. Because when it becomes a legal matter, right, the attorneys will look at that and say, well, you didn't really have any kind of information. What if the system is not theirs, right? What if the smartphone has been changed? So you don't want those type of questions. So want to make sure that you have proper practices. Question? I think I talked a little bit about legal hold with you guys last time, right? I've dealt with legal hold for some part of one of the jobs. So question 8, when is legal hold conducted? And you typically see e-discovery is the company that most people use to handle legal hold. What type of tools is best suited for legal hold? So legal hold really means that it's litigation hold. And this would be conducted when the information is retained for legal cases for however long it lasts. Okay? And after. So if it lasts multiple years, like the example that I gave you before, like the company that I worked for had a legal hold for 2 years because there was investigation about their fraudulent reporting for their financial systems, right? So that means that all the information that was generated and used on their system is being monitored, retained, and investigated for 2 years, okay, by the FBI. So, and it could be different format, right? Different agency, different law enforcement offices. So they typically use e-discovery tool for legal hold. Yes.
Let's say there is a case and they table that information for years because there's a case, so what happens after this?
You have to retain depending on the industry. So typically that the evidence and the information about the case is retained for multiple years or at least 1 year after. You cannot shred that data because what if the same case or a branch off of that case resurface, right? Fraudulent case sometimes. So let's say that, my former company, the executive got fired, right? And they brought in the new CEO and they're saying a similar things happen again and they have another case, right? So we have to go back and look at, right, like the information on the system and if there was any kind of change and things like that on their financial system. So yeah, so you have to retain it a little bit after, depending on internal policy and also compliance. Okay, any question regarding 8? Number 9. When we did the malware analysis, right, some of you couldn't get the hash because the file was quarantined by Windows, so your tool did not allow you to generate the hash. But when you carve files, every file that you carve needs a hash. Okay, that hash is used to do a match. So let's say that you create an image, right? And you carve out the files. You said these files belong to system ABC, and these are the hashes. And then later on, right, we go back and we compare the hash because we want to show the court or whoever that's getting your report that the files is not changed the time that you acquired the system to investigate to the time that you hand it off. Okay. So that hash value just to validate that your files stay intact and it's not modified. So you need to use hashing utility in investigation because the the copy that you made of those files, right, needs to be validated that it's not changed. So there's integrity validation in that. So I introduced you to quite a few type, right? Like, so if you're doing like, if you're using a network forensic tool like Netminer, it has a hashing capabilities for like, if you are pulling files from that network packet. You can also use hash ID. And then when you did the PowerShell before, right? Like certutil in Windows allows you to generate a hash for a specific file. So technically, when a file is saved to a system, it already has a hash, right? You can use a hash generator or a hash utility to generate another algorithm type. Like I wanted to do a SHA-256 or SHA-256 instead of using MD5, right? So that way we can compare the hash later on and say that, oh, that file has been not been modified. You see a lot of this with downloads, right? So let's say that if you're downloading an application, they give you a hash because after you download, you're supposed to check that hash to see if it's exactly the same. If it has changed, then it might be embedded with something that you don't want or it's been changed. So. Okay, so in forensic, we're also performing software analysis, right? System resources analysis and encryption. Typically, because when we work with files, the structure and the nature of the file really depends on the operating system. So when you're looking at like iOS devices, that's going to be different than your Windows systems, right? Of course, because they're different file systems. So operating system is important. We need to lay that out, right? You need to find that information and say this system contains this operating system, right? And that's the file system that we're working with. And then the stored data on the operating system. And how the operating system handle tasks is also a little bit different, right? Operating system is really geared for specific type of hardware, really, right? Your software is always going to be correlate to hardware in this world. So what you see is that how your operating system utilize your RAM and your processor to execute tasks, right? Like let's say for an application, is very specific to the nature of the application. Now, you do see some software that is cross-platform, but technically, if you see the downloads for different platforms are different because there's different file system, right? So you also have to analyze, right, the memory processes. Now, memory processes plays a very important role in malware. And later on, you're gonna see that in the lab we touch on like portable executable files, like your PE. In Windows environment, your processes are typically exe. Malware can come in PEs, right? Like you can download something that you think it's an application, but it's not, it's a Trojan. So, and with that, it sits on RAM. It uses RAM to execute. So when you pull things that are volatile, do not turn the system off. If it's running, capture it while it's running. Because we wanted to see what's happening in the processes. If you ever do that with malware, right, you look at like how many processes it used. In a lot of cases where malware took over the resources, make that system unavailable, right, you're gonna see a drop in a lot of the exe, or when you go to task manager, you're gonna see a lot of processes that are running. And you might have to run it, without all the extra services. So that way it can free up the processes as well. Okay. Then RAM also will give you credential, right, and encryption information. But when you're performing endpoint system, here we're talking about like specific computers, server, desktop, laptop, you need to pull these things. Operating system, data, processes, encryption or decryption, and decryption keys. Memory dump, because memory dump tell us about processes in our application that's used, encrypted files, crash dumps, and hibernation files. So it is slightly different than what you see when we're analyzing um, specific things like malware, right? This is when you're looking at the entire computer, the entire server. I would typically also see like services and things like that if it's a server. So that comes back to like processes and so on. Question? Okay, let's take can I bring 9 down? Are you still working on 9? Let's put those together with the other ones. Okay, so that brings us to volatility and memory analysis. So volatility 3 is a tool that typically used for VMIM or memory image analysis. Memory, as you know from A+, right? RAM needs power to retain information. So in that case, we don't want to shut off the power because when you shut that off, it flushes the information. So when you do live memory analysis, you capture the image of the RAM or of the system and analyze it. RAM captures is a little bit different. So you would use tool to capture the state of the RAM and the data that's held at the addresses of the RAM. So that way you can see. But what can we get from that, right? Encrypted and decrypted data in state at the storage, because before it actually decrypts and put it onto your permanent storage, which is your disk, right? It has to go to temporary location because it's through an application. Encryption, you have to use an application to encrypt, right? Like for example, BitLocker for Windows to encrypt drive. Okay. And BitLocker allows you to encrypt the drive. You can download the key and save it, or you can print out the key. Not necessarily the best technique, but with encryption, you typically see passphrase, right, or passwords to be able to decrypt, depending on the tool. So the key has to match, and in order to activate the key, you have to have passphrase or passwords. So with that, these information actually is stored on your memory disk. Okay. Also credential, cookies, browser session. There's so many things that sits on RAM. So, so in the case of attacks and things like that, when you do forensic, likely that you're gonna have to capture this. Okay. All right. Any question regarding live memory analysis? So don't turn the power off, create an image of RAM in the system state, and then use the tool to analyze. This particular area, you will have to use RAM analysis tool, okay? Like volatility 3, which is created in Python. It can be run with the script also. Okay, so let's say that you work for the police department and they handed you some mobile devices and they tell you acquire the content of this, right? You would need to be able to log into their device. Now, most of the devices use biometrics, and Also, maybe a PIN to log in, right? If the biometrics fail, there's an alternate way to log in, like swipe, and so on. So, um, I was listening to a lecture last night. They were talking about biometrics, right? And the students were asking like, well, how can it be secure if your fingerprints is stored on your mobile devices, right? Or your face images is stored. Technically, none of that is stored your mobile devices. Do you know that? Right? Your phone and your tablets when you're using your biometrics, when you scan, when let's say I bought my new phone and I create my login, when you scan your finger, you know how they tell you scan multiple finger and do it multiple times. So it creates a template. It doesn't capture the image of your fingerprint. It actually create a numerical value that represents your biometric. Okay. So when you touch the scanner, it quickly looks at your fingerprint, does a math calculation based on the algorithm, and find a match. If it matches, then you can log in. If it doesn't match, if the value is not equal, so it's kind of like a hash value. Think of it like that, right? So it does a comparison of the value. Same thing with the face, right? How big or wide your face, your brows, all of that gets calculated into a numerical value. So none of that gets stored on your system or back into your iCloud or your Google Drive and so on. Okay. So if you need to get into the device and you don't have the PIN number, you're going to brute force it. Okay. And then that way you can unlock the device. But now the mechanism now for most of the mobile devices is that, especially Apple, right? If it's locked, you have to contact Apple because it's related to iCloud login sometimes, right? The data gets synced. So when you deal with the third party in digital forensic, guess what happens? You have to provide court order. It takes time for them to respond, right? They have to validate that you are working with this case legally, and then they will release the information like password to log in or PIN and so on. Okay. So brute force or specialized decryption to unlock the device because in the process of locking, it might encrypt some storage information. You need to, once you are able to access it, then you create an image of it. You need to back up that image and then analyze it. So it tells you here that you need to perform a backup of the phone or the device to discover the current deleted data on the device. So I would recommend analyze the image of it and then also see, but the slack space in the storage will tell you a lot about what's deleted. I was, you know, my friend that works at Riverside, San Bernardino County, I was telling you about one day we were just testing, and she was like, yeah, I wanted to run this software on my phone to see if it pulls all the email, right? So she did, and it pulls all the deleted emails from like 2 years ago, and it's crazy because it's able to access like her email account and all of that. So it's interesting enough that like how, you know, because the servers have also back up that information, and so the account gets synced, and so some software is able to pull that information. But did you know that it also pulls text? So even if you deleted some text off of your phone, but when you deleted text off your phone, your service provider back up your text for 3 to 5 years. Most standard mobile communication companies are required to back up your data 3 years, right? But so in the case that if someone is involved in a criminal activity and it relates to that, and the court order goes to the service provider that provides it, they can authorize the data set where they would give information. Sometimes you ask for that to be printed out. Have you ever seen that on like shows? Right? It shows like I've watched like a documentary on cyberbullying, and they pull all the information, all the images, all of the communication between these kids, right? And that's how they're able to pinpoint when it happened and how it happened. Okay. So we touched a little bit on hosts, right? Like endpoint analysis, memory analysis. We go to mobile analysis, right? And then now we're gonna talk about malware. Like I said, that will play an important role or area in your job. So a packer in a malware is a way that the attacker can mask the malware nature. Okay. Typically they would encrypt or they would use a tool to change the way that the malware looks. So in that, when your security application or your anti-malware application cannot detect the malware, it's because it's been packed. Okay? So packers are ways for the creator to protect the malware from reverse engineering, from being decompiled and analyzed at the bin file. And so the second question asks you, how should you begin to analyze a malware that contains a packer? You can use specialized virtual machine that is specific for that. We're going to see that today. But in malware analysis, you typically reverse engineer, but if you cannot, you need to use forensic tool to unpack, right? To unpack so you can see the source code and you can bring it to the binary level. Okay. That way you can decode it and see the functionality of the malware. And this is for a lot of the malware engineers, right? This is how they work on that. Any question? Okay. Now we're going to talk about log files and forensic investigation. So when you perform computer forensic investigation, what type of information that you can find with log files, right? Logs are our best friend. In the security world, what type of application can be used to view log files? So we talk in extent in the last few weeks about logs and how that plays an important role in network monitoring, right? In system monitoring. Log files can present to you the events or the incident that happens with your system by giving you the state of that system and at that moment in time. The activities or the actions that have been taken on by the system. So for example, like if your system has been logged in, right, successfully, if your system has files that are deleted, configuration that's been modified, service that's been stopped, right? So, and then, or when you have application on your system that has error, right? Like if someone fuzz your system, your application, it will generate a bunch of error and that gets recorded on the logs. So that means that the logs tells us the story behind the system, for sure. And logs can be a lot, right? You will have limited amount of time to parse the logs and find. So you have to find a smart way to read all of the information and put together a story. Okay, that's what we do with investigation. So you can use tools to be able to read your logs. And last week we talked about some of those, or the week before we talked about some of those tools, right? So that means that I can read it at the text level, right? Even a .log file or in Windows that gets recorded as events in event viewer, right? But you can convert that into text format or CSV and then be able to analyze it that way. Okay. I recommend learning how to filter, especially if you're working with servers that have no graphical user interface. You need to know how to use things like text editor, nano, you need to know how to use cat command, stuff like that in Linux environment. That's very important, right? And then how to apply filter with that so you can parse the log quickly and not like having to look through like a bunch of lots and lots of lines, right? That just can be very overwhelming. And then use the tools effectively to analyze large amount of data in logs. Okay, we talked about analyzing the network. We did a lab on malware analysis using Network Miner, right? So you basically capture the activity on the network using packet or protocol analyzer like Wireshark or Network Miner or whatever tool you use, right? T-Shark, Eteril, TCP dump. There's many different tools for packet analysis. So take the capture and then go through and analyze the packets, right? And we learn how to filter and look for specific things. So all of these things are going to be applied to forensic as well. So knowing how to work with network, right, protocol analyzer and reading the packet information can be important, or understand the packet information. I think Network Miner is one of the better tool that you can use for network forensic, right? It gives you, like you saw, credential information. Where Wireshark, you're gonna have to dig around a little bit, right? You gotta put in some filter to get like 3 steps in Wireshark will get you to like 1 step in Network Miner. And so, think about what tool would be effective for your job. Okay, everybody mostly use cloud service, right? Before you start touching cloud systems, even though you pay for the service, you have a contract with them for a long time, AWS, Azure, Google, anybody that provides your cloud service, to perform forensic or ethical hacking on these systems needs permission. So when you do forensic on cloud systems, ultimately they're just servers that are at their data center. You need to look at your contract to see if it's allowed. Okay. There will be clauses on your contract that would say, can you test your system limit, like ethical hacking? Can you perform forensic investigation? You know that they will protect their hardware level, but you are required to secure your systems if you use IaaS, right? And in the case where an incident happens similar to what you see with Canvas, right? If Canvas is housed with a cloud provider, they have to go back and see, can I do digital forensic, to look at the attack. Then you have to, with that, you would determine what kind of legal recourses that you can have with the vendor. Are they liable for some of the requirement in the investigation, right? So, and then you would need to identify the data that you need, whether you are using methods that you can control from your organizations or not. Okay. Like in the case that you have to work with them, you cannot have a complete control in your investigation. You would need to collaborate and find a set of processes, procedure to perform the investigation as you don't control the data. Remember that physically, that's like their system, right? And so even when you're renting their systems, right, they are the owner of the system. So there's some requirement in digging out the data on their system. Okay? So go back to contract, review it, right? In the case that you have to work with them, make sure that you have a clear plan on how you would approach that. Okay? Consult legal team, a lot of these things. Because in the case where it becomes a federal investigation kind of case, like most of the large breach, like what you see with Canvas, like a ransomware, you have to report to the FBI, right? That's where you would start with the response. and then you would have to find out like how it happened. So first you contain it, you bring everything back, and then now they're probably gonna try to close out all the security gaps. If you're not aware, they paid the ransom yesterday morning, right? The ask was $5 million. It says that they settle on an agreement, so I think it's right under. So the data that they got on all the students, the faculty, all of that, your email, right, your ID, I'm sure you read some of them. Communication, so Canvas messages, they inject through the browser. So we just talked about that in ethical hacking on like pulling the stuff from the database. And then, but you know, the core in that database is great. What are they? So yeah, they had until yesterday to pay up, and they did. I thought they wouldn't, right? That's really a decision of the executive of that company. From a perspective, if you pay for the ransom, that there was evidence that they shredded the data, right? So that's how they got paid. Um, if they have cybersecurity insurance, they can make a claim and get some of that money back, but it's not guaranteed because it might be like you have to report how much data was involved, and then based on your contract for your insurance, sometimes they'll say like if your data is $20, they'll pay $1, right? Like a fraction of it, but at least it's some money back. Or sometimes they would reject your claim, and you have to go back, and then you try to do it again. So, it varies. So, and also the type of insurance company that you have. Yes. Um, Based on the media and some information that I acquired, that there has been evidence like video or activities that shows that they deleted the data that so Canvas had gotten somebody to go into the dark web to see if the data was leaked from Canvas. You can use tool to map it too. In the dark web during this time, and there was nothing that was, and Canvas doesn't have a lot of your really, really sensitive information. I think the most is like your email, maybe personal communication with the faculty, like on your Canvas messages, but it doesn't have your social security number, your phone number, maybe your profile information, but anybody can customize their profile to what they're liking, right? But those are the things that they got. So I was told that they shredded it. So there have been so they confirmed it, and that's how they got. Cool. So we still got a little bit to go, so I'm hoping that we can end a little bit before 7. Okay, we talked about cloud array. When conducting forensic investigation on VM containers, what are the restrictions? So typically you would see container related to cloud or VM related to cloud, because if they're running Hyper-V, right, that could go back to Azure server, or if they're running EC2 with AWS, that will be like a lot of the server roles can be run from a virtual machine on AWS. So when you are performing investigation in the virtual machine or in Kubernetes or Docker containers, right? We talked about containers and VM, they're different, right? You guys have a lot of exposure in VM because I make you use VM because the world that we live in is a lot of it is VM. Containers are just allocated storage that you can have VM within, or data content or applications that you can run. Some of your lab, I require that you set up a Docker, right? And that Docker can sit on a remote server. So what are some of the restrictions and limitations, right? If we're just looking at these components as themselves, not related to the cloud, we need to really look at like what can be copied from the virtual machine. So as you know, in a virtual machine, if you create data, you just need to extract that data from the VM outside, right? I've shown you technique like you can put it on to a USD and transfer it, right? But you also need to capture the state of the VM before you go in and look around in it, right? So the forensic toolkits allows you to do that. I'm sure if you look on YouTube, there are tutorials on how to create an image of a virtual machine. You spin up the virtual machine like how you boot up a computer, right? Or sometimes you would take the state of that virtual machine and you basically recreate that virtual machine as an image, and then you would analyze the content. So you wanted to see what you can pull from the virtual machine, like carve out the file, pull the information. You also need to look at file system, internal lots, software, network services, modification to their network connections. This should be broad. Sorry, it says bot. Okay. So containers sometimes can be enabled to be connected online or taken offline. Same thing with VM. And so, or moved, relocated. So when you look at it that way, you kind of have to treat it like it is a container, right? VM is in a folder, right? The files in that folder, the state, the logs, the files that we ran with your virtual or your hypervisor, etc. So we wanted to see if we can pull some information or modified information about that particular container. Okay. Many companies have instances, right? If you ever scan Nmap, they run it on a VM. A lot of web servers are spin up on as a virtual machine instance. Whether it's hosted in their network or in a separate network that's leased. So you will work with containers and cloud and VM a lot. Okay, coming back to Windows, what kind of artifacts can you find of the deleted files? We talked about where the deleted files go. The space of the deleted files is a slack space. We talked about registry containing like changes to the system, but what you can do, find in specific to files that are deleted using index files or change logs. So anytime that's deleted, it gets recorded in the log. So you want to look for information on the logs that has anything related to changes to the files. And then you will pull the logs for the application that are used for those files. Like if, let's say that I am looking for like Word document, then I would look for the logs that are related to that application, Word, Microsoft Word. All right. Any questions?
So this is, if you do something off, not in the trash, it's how you find something.
Yeah. So if let's say I press delete on my keyboard and typically that in Windows it goes to recycle bin and I empty my recycle bin, it's still in Slack. And when you delete, your system records that you delete. Your system records everything that you do. So I always say there's two things that you cannot lie to a security professional, right? What you have done on the network and what you have done on the system, right? A good professional would know exactly what you've done on the network and on the system. Okay, because everything comes through the network, downloads, uploads, things like that, right? And as it arrives to your system records it. So if you know how to read logs and you know how to read network packets, you can see everything. So now think about that, right? And I mean, you're entitled to your privacy in your own network, but when you're using someone else's network, just be careful what you do, right? Because you never know who's looking and what they're looking for. All right. 19. How is forensic image created? Right? What must be done to validate the system image and forensic? So we already talked about using image utility. But when you are using systems, right, as you connect them to create an image, like I have a computer that I'm running my forensic application to analyze, and my target system, the system that I'm analyzing, I connect them together so that way I can transfer, right? I can transfer the image, or I can connect the drive to the target system to capture its image. So in that sense, you need a write blocker. The write blocker allows us to protect the image and not change the content of that system as it comes across. Because your image utility takes the information of that system and bit by bit it writes. This is why forensic takes a long time in capturing an image. So just imagine, right? Many of the systems now don't just have 1 terabyte, might have 2 terabyte, 4 terabyte, 10 terabyte, but it does bit by bit copy. Okay. And you calculate out, right? Byte is 8 bits, right? Terabytes, right? So you do that you exponentially, you are gonna, and how fast is your system that's copying, right? So that's gonna take time, but it does a bit by bit imaging. I learned this the hard way where I gave my student, some of you were in that group, a USB that's 2 GB, and they were trying to make an image of that USB in the time of lab. Not happening, right? Also, there's a limit in the image utility. The maximum piece, an image file is 2 GB. So if you have terabytes, you're gonna have a bunch of image files. Okay. All right. You need a hash to validate that your image stay intact and it doesn't change throughout. Okay. So first, when you create your image, record its hash. Later on, after you perform analysis, check its hash. Put those things on the report. This is the beginning hash. This is the end hash. This is what I found. Nothing has been changed in this investigation, but this is what I discovered, right? All right. Why should we avoid using copy command to create your forensic disk image? You have to use an application to do this because if you do CP command or copy command, it does not pull the extra part of your disk that we want to look at, the slack and the unallocated. So let's say I wanted to copy this A, right, or this C to my USB, right, to really look at the content of the disk, or the USB to a USB. It doesn't pull the slack or the unallocated space. And we talked about the difference. Now, DD is a very common tool. It's been around in Linux for a long time, right? It was used to create partitions and things like that. But DD typically is used in forensic to create image. You can use it as a command. It's built into your Kali Linux and many different variation of Linux, Debian Linux. And DD creates block size. So each block contains 512 bytes. Okay. Now you can use your standard block, which is 512 bytes, or you can use larger block size because your large block size would increase the speed but reduce the write time. So that way it shortened the time. Just imagine that, let's say that you have 2 GB, right? If you chunk it into 512 bytes, 512 bytes is going to be that amount of time that it's going to write. But if we chunk it into larger block size, so on some of these applications, it allows you to set your block size, right? So we want to go higher than this, where it would take a shorter time to run. You have less block, right? Less blocks to actually store as an image, so it reduces the time to store, but it's faster to read. So let's say that it takes, if we use 512 bytes, we have 10 blocks, right? Where if we use something double that size, we would have 5 blocks. So it's shorter to write, to save, and it's faster to go through each block. Okay. Now, not all tools allows you to change blocks. Some tools are specific to its size, so that's what you're gonna get. Any question about 21? This is a little longer, but I'm trying to still keep the time to 7. So you are gonna click this link, right? I go all over all this. So basically, one of your unit is kind of like a summary of 27A. It's not everything that you need for forensic, right? But at least it's an overview of what you use and how you use it and why. But this is a website that was created by NIST. It allows you to check for the tools that you're using. They validate the tools. So I can't just go on Amazon and buy these tools or the internet to find these tools. In forensic practice, right? If you want to make sure that you don't get questioned about your technique and tools, you validate. And the way that we validate is we use a tested tool. Okay. So there's tested software like the application, the forensic toolkit. There's also hardware that's been tested. So when you click that link, control click, right? You go to this site. You can select any of these. These are different tests, write blocker hardware, that's actual device. They run on average, if you look online, $200-300 or higher. You can click any of these and go through the document. I just want you to be able to be familiar with this in the case if you need to check right before you buy your write block. Okay. Or if you are given one, you need to check to see if it's tested. Okay. You can also submit your tool if it's new for testing. Many people do, right? Different organization they would submit, and this would go through the process. It will take a little bit of time. So let's say that I click the first link. It takes me here, right? Or it might take me to the document, the beginning. Yeah, it stores my cookies, so it remembers, right? You can read through like the tool that they have tested, how they tested, and what kind of results. But if you go to case summary, just click case summary and it will bring you down to this section. You can see some details about the setup of the analysis, right? I'm only interested in this, like, so in this part right here, not this part, I want you to look for the answer for these things. What is the result key and what tool was used to test? Okay. So look at the end of the document that you have selected and you should be able to answer these questions. Why do I need to write this down, right? I'm not just making you write down to keep you busy, but you need to put this information on your report if you're selecting that tool. So let's say that I use a write blocker to transfer my image to my hard drive or my external drive or my SSD on my system to analyze, right? I need to put this on the report. This is the write block that was used, right, in this investigation, and this has been tested when, and this is the result key for the test, and the tool that was used for the test is this, and it was done by NIST, right, on this date. So you need to read the documentation to see. right? Any questions?
Nick, do we click on again?
You can click on any of the ones that were provided. They would be different right blocks. So this is a Kangaroo SS3, but if you click the next link, that's a different model, right? Some of them are USB, some of them are not USB. So if you read the description, right, this is the brand for Kangaroo. But if you go down further, you can see like Apricorn, Cinnabis, there's different type, right? Just different brand, different model, right? So you can just select any of the right block. These are the recent one. And then if you go to 2024, right? And then even older. So if you are given or you bought an older, if you watch my last video, I think we were looking at like Tableau, or so select any of them, and if the documents is really short, right, a few pages, so if you scroll down, you look for that information, you can do Control F to search for specific things on the document. Okay, so I want to show you how. Now if you are using this source to look for other things like so on the left you will be able to find like specific category, right? If you're using stuff for mobile devices, they have some information. If you are file carving, right? They have a list of file carving tools that they have tested, right? And so like FTK, different versions, RStudio, different version, etc. Scalpel. Scalpel is very popular too in forensic. NKs. See? But check the version number, that the one that you're working with, and then check the test site. Okay? All right. Just a few more. Oh, I might go over a couple minutes. All right, let's get through these real quick. So when you capture a live image of a system, the system that is running as you capture the live image, right? When should you do that? So when the system have full disk encryption, that means that if the drive that they're using has encryption, right? Like using BitLocker or another form. When they have applications that are running, right? Or malware that is infected that system, because you want to capture the state of memory. So don't turn off those computers. Keep them running, and you need to do a live capture. That means that you need to connect your system to that system and run your image utility. Okay. And then capture, so it does bit by bit copy. Go get coffee, right? Come back, wait until that's done. So it's going to copy the state of that system, the application, the data, because if you turn it off, it would lose some of the information about the application, the malware, right? Possibly encryption information. 24, the limitation of live imaging, which is what you see in 23. The limitation with that is that it would leave remnants of your imaging utility. Like I said, right? There's a little bit of contamination with the artifact, because you have to mount drives like USB drives or your drive to it. And in the mount, it's a process of recognition of drive. So there has to be a little bit of change. The content of the drive or the memory might change during the imaging process. So when the content of the RAM, it's going to be inspected and pulled and copied into the image, there might be a little bit of change or loss. In the case of malware or some application, if it sees imaging tool, it might terminate, right? If they wrote the malware for that. You do see some malware that has that feature. And live images do not include unallocated space. So if you're trying to file carve in the space, you have to do offline imaging. That means that you have to turn the system off. Eventually you will. After you capture the image, you have to capture while it's off. So take another image after you shut it down, right? But make sure you have the live image first. Earlier we talked about logs. What kind of tools can you use to access logs or logs content? Splunk, very popular. RCC used to have this class, will no longer be offered. I just met with them last Friday. They took it off the catalog, but you can learn Splunk via the internet, AI, and the website itself. Sawmill, Event Log Analyzer. These are just a few. Or your best friend in Linux, Nano, your other best friend, your text editor. So if you're using Apple systems, right, I always get that question in Java class because I make them run it in command line. Because when you get to the university, some professors will make you run it in command line. But guess what? If you're working with web servers, right, a lot of them just run terminal, no desktop. We're gonna see that today with RVM, right? So you need to know how to use text editor, but in Apple system, you can use text edit or you can install Nano. And then lastly, 26, what type of tools are used to capture memory resident data in Linux system? You can use FMEM. Lime is another one. I think Volatility 3 will allow you to do that as well, but those are the primary ones that you see. So FMEM uses DD, like what we talked about before. DD can be used to capture storage, image, or other similar tools. Lime does direct data copy to a file or of a directory. All right. Any question? Okay, so before we go for a break, today we're going to use a different type of virtual machine. It is a Debian machine, a spin-off of Ubuntu. So it won't be as hard, right? The process of loading it is a little bit different. Pay attention to my instruction. I modified the lab document since Monday morning, right? Like as I end class on Monday night. So I read it out the steps that you don't have to do because originally that lab was written with 2 PE, the CMD executable and the install CMD executable. They are malware PE. I'm going to have you download it from a GitHub repository and then use that VM tool with, you know, the one of the tool we're going to install, we're going to run it. And then, you know, so download the lab document, go through it, make sure you pay attention to the instruction. If you need help, call me and I will help you. Okay, but it should be pretty straightforward and easy. All right, let's end Zoom.